Hello and welcome to this film, which is all about gases basically, and things to do with moles of gases. So hopefully before watching this film you've already watched a few films about mole calculations and you know a bit about those things. Here we're going to be looking at the formulas that we use to calculate numbers of moles of gases and their volumes. And so hopefully by the end of this film you'll know what the symbols for volume, pressure, temperature and the gas constant are, and you'll have practiced using a couple of formulas that are different depending on the conditions that we're under. So here are those formulae. Now there's no need to remember these, okay, because they're on your data sheet, but it's sometimes quite handy if you can figure out what they are, because then you can check that what you're doing is making sense. But anyway, let's have a look at them. First, we'll start off by looking at this formula, which is V equals N times 22.71. 22.71 is called the molar volume of a gas, and it's only the case at STP, and that is to say 0 degrees centigrade and a pressure of 100 kilopascals. Now what do we mean by the molar volume of a gas? Well, I suppose it's quite like the molar mass of a substance, which is the mass of 1 mole. This is the volume of 1 mole of a gas, and you might expect that it would be different depending on what gas you're using. But for reasons that we'll discuss in more depth later in the kinetic theory topic, that's not true. In actual fact, it doesn't matter what gas you have. The volume of 1 mole of it will always be 22.71 litres at standard temperature and pressure. Okay, so that's the first formula. That's, I suppose, the simpler one, because we have a bit of a shortcut because we know what the conditions are and they're these particular fixed conditions. If we're not doing things at STP, then we need to use this formula, PV equals nRT. Now what do the symbols stand for here? Well, P is still pressure, V is still volume, little n is still the number of moles, R is something called the gas constant, and you find it on the data sheet, so there's no need to remember it, but its value is 8.314. And T is a temperature in Kelvin. Now it's really important to realise that kelvins are not the same as degrees centigrade. In fact, 0 degrees centigrade is equal to 273.15 Kelvin. Now again, that's not an important number to remember because it's on our data sheet, but it is important to know how these things are related. Now 1 degree centigrade is the same as 1 Kelvin. It's just that the starting points for the scales are in different places. So if I had 0 Kelvin, I'd be at minus 273.15 degrees centigrade. So in other words, if I've got a temperature in degrees centigrade, I simply add 273.15 to it and I'll have my temperature in Kelvin. Okay? So anyway, they're the two formulas we use. They're on the data sheet. Let's have a look at how we might use them in some examples. So first of all, we're going to find the volume of a gas if we're given its number of moles at STP. And we're told here that we've got 0.025 moles of nitrogen dioxide. Now we might be wondering, well, what's the formula of nitrogen dioxide? And it's NO2, and hopefully the name tells us that. But it's irrelevant in this question because it's what we call an ideal gas. It obeys the usual rules and we're at STP. So we can use the formula that the volume of a gas is equal to the number of moles times 22.71. Okay, and if we plug in 0.025 into that formula as our number of moles, then we can find the answer using our calculator, or if we're very good at mental arithmetic, I suppose, or well, better than me, and that's 0.568 litres. Now I've given that to 3 significant figures. 3 significant figures is always a good idea in your mole calculations. If you give your answers to that, then you won't be losing marks. If I'd written lots and lots of significant figures here, then the marker might think, well, I'm making stuff up because I don't have that many significant figures in my data. In actual fact, I suppose you could say that I should only be giving my answer to 2 here because I've only got 2 significant figures there. But as I say, 3 significant figures, if you follow that rule, it's very rare that you'll ever get penalised. Okay, now we're going to kind of do the reverse problem. We're still at STP, and we're going to find the number of moles when we're given a volume. So here's a volume. Now careful here because this volume is in millilitres, not in litres. And our volumes always have to be given in litres if we're going to use those formulas. So we've got to know that there are 1,000 millilitres in a litre, and that means that we've got 0.165 litres here. Now, if the volume equals the number of moles times 22.71, then hopefully we can rearrange that and say that the number of moles is equal to volume over 22.71. Okay, and if I plug in my volume here, which remember is 0.165 litres, not 165 because we're in millilitres, divide that by 22.71, I get an answer of 7.27 times 10 to the minus 3 moles. Okay, once again, 3 significant figures there. Okay, moving on, and now we're finding the volume from a number of moles, but now we're not at STP anymore. So we should hopefully remember, but if we can't, we can use our data sheet. PV equals nRT. This is a formula that we use. It's called the ideal gas law, and it's something that we can use when we've got a specified temperature and pressure that aren't standard. Okay, so what numbers can we put into here? Well, we know the number of moles, we know the temperature in Kelvin, and we know the pressure. We're trying to find the volume. So the volume equals nRT over P. You might be thinking, well, I don't know what R is, but it's on our data sheet. Remember, it's the gas constant, so that's 8.314, and then multiplied by 1500 for the Kelvin temperature, and then divided by 125. And once again, plug those numbers into your calculator, and you get 150 litres to 3 significant figures. Okay? So, here's another example of a question that is not at STP. It's the reverse of the last one, so this time we're finding a number of moles. Remember, if PV equals nRT, then that means that the number of moles must be PV on RT. Okay, and what values can we plug in this time? Well, we've got 500 millilitres, so that is half a litre, 0.5 of a litre. We've got a temperature in degrees centigrade this time, so we've got to watch out for that. And we've got a pressure of 200 kilopascals. So I've got 200 times 0.5 for my volume, because I've got 500 millilitres, divided by 8.314, multiplied by 273.15 plus this value, so 298.15. And once again, my calculator has told me that this is 0.0403 moles. Okay, now we're just going to do one final problem where we're asked to find a volume from a mass. Now, none of these formulas that we've looked at so far have got mass in them, but we should know from the stuff that we've done before that we can find the number of moles if we're given a mass. And that's mass over molar mass. Okay, so here I've got not standard temperature and pressure, so I'm going to have to use PV equals nRT. And we're saying here that we can't just plug the mass into this because we don't have mass in this formula. So we've got to find the number of moles of nitrogen before we can start. Now, a common mistake here would be to say that the number of moles is equal to 25 over 14.01. Okay, that would be wrong because that would be treating nitrogen as if its formula was N, but its formula is N2. Okay, so in actual fact this equals 25 over 28.02. Okay, and I plug those numbers in and I find that that's 0.892 moles. And now I can put that number into my formula. I'm trying to find the volume, so V equals nRT over P. And that now equals 0.892 times 8.314 times the temperature, which is again in degrees centigrade, so I'm going to turn that into Kelvin, 293.15, and then divide by the pressure, which is, oops, not 200, but 100. Okay, and that gives me 21.7 litres to 3 significant figures. Okay, so there in that final example, we've kind of linked the stuff about mass and moles to the things that we've been talking about mainly in this film, which is volume and moles. But hopefully now you think you know the symbols for volume, pressure, temperature, and the gas constant, and you can do these conversions and you can decide which formula to use depending on what conditions you're under. As usual, if you've got any questions or comments, please come and see me or post a comment on YouTube.